Hi everyone, welcome to Elementary Algebra. Problem solving is the focus of this class. So in chapter 1, we're going to lay the foundation for the problem solving approach that is developed in chapter 2 and used in all chapters that follow. Okay? So in this video, we're going to cover 3 topics. Number 1, evaluating algebraic expressions. Number 2, translating to algebraic expressions. And then number 3, translating to equations. Okay, so let's start with evaluating algebraic expressions. Probably the greatest difference between arithmetic and algebra is the use of variables. So what is a variable? A variable is a letter used to represent a number, usually an unknown number. An algebraic expression consists of variable or variables and or numerals, numbers, often with operation signs and grouping symbols. For example, x plus 9 contains the variable x and the number 9. And we call this a constant because the value does not really change. And we have the operation of addition. Okay, how about 4ab? 4ab contains the variables ab, okay, and the number 4, right, and the operation of multiplication. So 4ab is really 4 times a times b. So you notice that there are multiplications here, right? Okay, all right, and the last one contains the variable y, okay, and the grouping symbol, parentheses, okay, and the operation of addition, and also multiplication. Wait, multiplication? Where, right? Well, multiplication can be written in several ways. So for example, right, let me just move over here. For example, let's say 5 times y. 5 times y, okay, can be written as 5 times y, like that, okay? Or 5 times y, okay? Or 5 times y, like that. Or simply 5y. This means 5 times y, okay? So in the expression, 5 times the quantity y plus 2 right here, right? So there is a multiplication here. In between 5 and the quantity y plus 2, okay? 5 is multiplied to the quantity y plus 2. Okay, so to evaluate an algebraic expression, we substitute a number for each variable in the expression and calculate the result, okay? And this result is called the value of the expression. Okay, so let's take a look at this example. Number 1, evaluate each expression for the given values. A, c plus d over 3, or c plus d divided by 3. For c equals 14 and d equals 13. Okay, so we're going to substitute 14 for c and 13 for d, okay? And then carry out the calculations, all right? So it's gonna be 14 plus 13 and then divided by 3, all right? So 14 plus 13, that's 27, and we're gonna divide that by 3. So that will be 9. Okay, that's it for that. All right, so for B, you can pause the video and try it on your own and come back to check your answer, or you can keep watching. All right, so 9m over n. So 9m divided by n. Okay, for m equals 6 and n equals 18. So I'm going to substitute 6 for m and 18 for n, right? Now, what does 9m mean? That means 9 times m, right? So we are multiplying 9 by 6. So 9 times 6 over 18. Okay, so 9 times 6 is 54, and we divide that by 18. So that will be 3. Okay, let's box our answer so that's clear that that's our answer. All right. Okay, the next topic, translating to algebraic expressions. So our ultimate goal is to translate problems to equations, but first we need to be able to translate certain phrases to algebraic expressions. Okay, so let's go over some common words used to represent different operations. All right, so for addition, common phrases are added to, sum of, plus, more than, increased by. Okay, and then for subtraction, we have subtracted from, difference of, minus, less than, and decreased by. And for multiplication, we have multiplied by, product of, times, twice. Twice means 2 times. 2 times. And then of. And then for we have a division, divided by, quotient of, divided into, ratio of, and then per. Okay, let's try some examples and learn how to translate to algebraic expressions. A, 6 more than t. Okay, so the phrase more than corresponds to addition. All right, so 6 more than t is translated to t plus 6. Okay? B, 16 less than t. The phrase less than corresponds to subtraction. So 16 less than t is translated to t minus 16. Now, is t minus 16 the same as 16 minus t? Well, no. So the order in which we subtract affects answer. But then how do we know which order is correct, right? Well, when you see the word then or from in a phrase of subtraction, write what follows it first. So 16 less than t, t follows the word then, right? So you write t first, then subtract 16, okay? All right, so these two expressions are different. Okay, more about that in the next section. Now, actually, the same thing can be said to division as well. The order matters, right? So let's take a look at the next example. Okay, C, the quotient of x and y. The phrase quotient of corresponds to division, right? So x divided by y is translated as x divided by y, like that. Okay, not y divided by x. Okay, this is not good. Okay, well, this looks like x, but that's not good. All right, the order matters. So what you see first goes to the numerator, and then what you see second goes to the denominator. The quotient of x and y is x over y, x divided by y. Okay, the next one. The product of 9 and twice w. Now the word product corresponds to multiplication. Okay, that's multiplication. Also, the word twice corresponds to multiplication as well. Twice means 2 times. Okay, 2 times, right? So the product of 9 and twice w is translated to 9 times, okay, times twice w, 2w, okay, 9 times 2w, right? That's it. All right, next one. 5 more than 1/4 of some number x. Okay, so notice that 1/4, this one right here, 1/4 has the same implied operation as twice. But instead of doing 2 times, we're doing 1/4 times. 1/4 times. This one, we're doing 1/4 times. The word of is kind of a good indicator as well, right? Okay, so 1/4 times. So this part right here is translated to 1/4 times x, or simply 1/4 x, okay? And it says also 5 more than, right? So the phrase more than corresponds to addition, okay? So our final answer would be 1/4 x plus 5. All right, okay. F, 5 times the difference of two numbers. Okay, so the phrase difference of corresponds to subtraction, right? Now, it just says two numbers, so let A and B, okay, represent two numbers. You can use any letters you like. So the difference of two numbers is translated to A minus B. All right. Now the word times corresponds to multiplication, right? So 5 times A minus B. So 5 times the quantity of A minus B. Okay, so this is the answer. Now note here that what you don't want to do is 5 times A minus B like that. But why? Well, if you write it like that, this implies that 5 is multiplied only to the variable A, not to the difference of A and B, not to the quantity of A minus B. What we want is we want to multiply 5 by the entire quantity of A minus B, the difference of A and B, okay? Not just to the variable A. So it's important that we put the grouping symbol there, okay? So this is not the correct answer. Okay, the last topic of this section is translating two equations. Okay, now the equal symbol indicates that the expressions on either side of the equal sign represents the same number. An equation is a number sentence with the verb equal, right? So there are some words that indicate equality is the same as, equal, is, are, was, were, and represents, okay? All right, so it is important to be able to distinguish between expressions and equations. So expression versus equation, right? So no equal sign appears in an expression, okay? So no equal sign, okay? For example, 2x minus 1 plus 3 times the quantity y plus 2, right? Take a look at this one. Well, there is no equal sign. So this is an expression, okay? Now for an equation, equal sign appears, right? So equal sign appears, okay? And an example will be something like 2x minus 1 equals 3 times the quantity y plus 2. Now, when we translate a problem to an equation, we first translate phrases to algebraic expressions, and then the entire statement to an equation containing those expressions. Okay, so let's take a look at some examples. 8. What number plus 14 is 100? Okay, so we're going to let an x represent the unknown number, okay? Now, what number plus 14 is a phrase, right? And it is translated to x plus 14, okay? And is translated to equals, right? And then 100. All right, so this is the answer. X plus 14 equals 100. Okay, it says do not solve, so setting up the equation is enough. Okay, so if you want to try the next one on your own, go ahead and pause the video and try it on your own and come back when you're done. Or you can just keep watching. Okay, B. 1 less than the product of two numbers is 72. All right, so now we have two numbers, right? So we're going to let, let's see, just x and y, okay, represent the unknown numbers. Okay, now the operation that corresponds to less than is a subtraction, okay? And the operation that corresponds to product of, that's multiplication. Okay, so the product of two numbers is translated, this part here, okay, translated to x times y, or simply xy, okay? And 1 less than the product, 1 less than the product. Remember, you have than in a subtraction phrase, what follows it comes first, right? So it's going to be xy minus 1, not 1 minus xy, okay? Xy minus 1, all right? And then is equals, and then 72. There you go. So this is the answer. Okay, that's it for this section, and I will see you in the next video. Bye, guys.